Welcome to the Deep Dive. Today we're tackling a topic that's, well, absolutely central to modern business intelligence,
Right,
and our
yeah.
mission to really cut through the noise, the complexity, and pull out the essential concepts you need to know. Maybe you're just curious, maybe prepping for a BI role.
Yeah, and we've got a great source for this. It's an article that compiled, I think, over 60 key interview questions for BI folks.
Wow, okay.
Yeah, it covers, the real basics all the way up to advanced stuff, specific tools too.
So think of this as your shortcut, maybe, to understanding that core engine of, well, data-driven decision-making.
Mhm.
We're going to unpack this source, pull out the really important nuggets, and hopefully give you a solid grasp of what BI actually is, why it matters,
Yeah.
all based on the insights from this article.
Exactly. And it's not just about listing questions, right? It's understanding the why. Why BI? How do the pieces fit? What problems does it actually solve in the real world?
Yeah.
We'll try and pull out those, practical examples the source uses to make it stick.
Okay, let's unpack this then.
So first things first, what exactly is business intelligence? The source defines it pretty clearly. Using technologies, using practices to analyze data.
To make better decisions.
Fundamentally, yeah. Supporting better decision-making in an organization.
And why is that so, well, critical now?
Because being able to get actionable insights from just the sheer amount of data companies have.
Yeah.
That's the key, isn't it? Improving performance, hitting strategic goals.
BI is that whole process of turning raw data into something useful, something meaningful.
That's it. It helps companies, spot patterns, identify trends, maybe uncover opportunities they just wouldn't see otherwise.
Turns the data flood into a clear picture.
A clear picture for action, yeah.
The article had some great, really concrete examples, like retail.
Oh, yeah.
Using BI tools to track very specific customer buying trends. What are people buying, when, where?
Which lets them optimize inventory, right? Make sure the popular stuff's in stock, cut down on waste.
Exactly. Or think about finance.
Analyzing huge amounts of market data.
Spotting investment opportunities, managing risk, identifying potential downsides based on past patterns. All BI.
And healthcare, too. Analyzing patient outcomes to improve treatments.
Yeah, finding best practices, allocating resources better. It's really changing how businesses work everywhere. It's not just a tech fad.
Absolutely not. So, okay, how do you actually build a BI system? There are several key building blocks. So the source breaks these down, the main components that take raw data and turn it into those insights.
Right. And often at the center, you got the data warehouse.
The data warehouse, yeah. This is where you centralize data from all over the place.
Sales data from different regions, customer info, website traffic.
Everything. But it's specifically structured and cleaned up for analysis. That's the key difference.
Tools like Amazon Redshift, Snowflake, those come up a lot.
They do. But how does the data actually get into the warehouse? That's the ETL process.
Extract, transform, load.
Exactly. It's like the pipeline. Pulls data, cleans it, reshapes it, then loads it into the warehouse.
Okay, so data's in the warehouse, it's clean. Now what?
Now you need to make sense of it. Data visualization.
The dashboards and reports.
Yep. Displaying trends, patterns visually makes it easier to grasp. Tools like Power BI, Tableau are huge here.
And sometimes you need to go deeper, right? That's data mining.
Yeah, using algorithms to find those hidden patterns, relationships in really large data sets.
Things you wouldn't spot just looking at a chart.
Right. Like predicting future sales based on, I don't know, a whole bunch of complex factors.
That retailer example, again, really connects these, doesn't it?
It does.
Consolidate sales data, that's the warehouse. Use ETL to clean up inconsistencies between stores.
Then maybe use data mining to see how a promotion in one place affects sales somewhere else.
And finally, visualize it on dashboards so the merchandisers can see it quickly and act.
Precisely. Now, a really fundamental distinction you hit early on in BI is OLAP versus OLTP.
Right. The source was clear. OLLP for analysis, OLTP for transactions.
Think OLTP, online transaction processing. That's your day-to-day operational systems.
Processing an online order, updating inventory when something sells, a bank transaction.
Exactly. It's about capturing data quickly, reliably, handling lots of simple queries. Record this, fetch that. Speed and volume of transactions.
Whereas the OLAP online analytical processing, that's different. That runs on the data, often the data sitting in that warehouse.
Right. It's designed for analytical queries, complex ones.
Like, show me total sales last quarter by region and product.
Exactly. So OLAP deals with big volumes of historical data, and the queries are more complex. You're slicing, dicing, aggregating. looking for insights.
They really work together, don't they?
They absolutely complement each other. OLTP captures what's happening now.
And OLIF analyzes all that captured data to understand what happened, why, and maybe even predict what's next.
So let's dig a bit deeper into that foundation, the data warehouse and ETL.
Okay.
The data warehouse, it's more than just a big database. It's designed specifically for analytical work, pulling structured data from potentially, dozens of different systems.
And its role in BI is just critical. It brings all that separate data together, clean, consistent.
Integrates things like your CRM, your ERP system, maybe even IoT device data. That consistency is vital for accurate analysis.
Yeah, you can't compare apples and oranges.
Exactly. And it hugely enhances analytics because you're not bogging down your operational systems with complex queries. You query the warehouse, which is built for it.
That multinational company example, consolidating global sales. Perfect illustration.
Totally. Imagine trying to do that with just spreadsheets. Nightmare. The warehouse gives you that single version of the truth.
And tools like Google BigQuery, Amazon Redshift, Snowflake, they're built for this scale and integrate smoothly with BI platforms.
Right. Now, ETL, the unsung hero getting the data in. Extract, transform, load.
Extract is just pulling the data from wherever it lives. Databases, APIs, flat files.
Yep. Like pulling customer data from all your different touch points.
Transform is the really crucial cleaning bit, isn't it?
It really is. Standardizing formats, dates, addresses, handling missing stuff, getting rid of duplicates, maybe doing some calculations.
Tools like Talent Informatica are mentioned for handling that complexity.
They are. And then load is just putting that nice, clean, transformed data into the warehouse ready for analysis.
And ETL tools automate this whole pipeline. Talent, Informatica, Apache Nafi, making it efficient, reliable.
And that reliability is so important, which brings us to data accuracy and metadata.
Yeah, why does accuracy matter so much in BI?
Well, because bad data leads to bad decisions. Simple as that. Garbage in, garbage out.
Right.
The source highlights best practices. Automated error detection during ETL, validating data at every step, auditing your sources regularly, catching issues early.
And then metadata. That's data about data.
Exactly. Where did this data come from? When was it updated? What does this column actually mean? Who owns it?
It sounds kind of dry, but it's incredibly important for BI.
Oh, absolutely. You can't overstate it. It makes things efficient. Analysts can find and understand the data they need.
It's fundamental for data governance too, right? Knowing who's using what.
And it just makes everything searchable, understandable. It's like the library catalog for your data.
Okay, so we have clean, reliable, well-documented data. Now we need to show the insights, dashboards, reports, visualization.
Right. A dashboard is that visual display, key metrics, designed to be understood quickly.
A snapshot, often real time, pulling from different places into one view.
So decision makers can just glance and see what's going on.
And data visualization is the broader idea. The art of showing information graphically.
Yeah, making trends and patterns jump out. Simple things like bar charts for comparisons or heat maps to see highs and lows quickly.
Translates numbers into something intuitive.
Exactly. Now, the difference between a report and a dashboard, that's important too.
A report is more static, right? Detailed summary, like a monthly sales PDF.
Usually, yeah. Whereas a dashboard is dynamic, interactive, focused on those key performance indicators, KPIs, with live visuals.
And slicers, those filters on dashboards.
Yeah, they let users interactively filter the view, see sales just for one region or one time period. Makes analysis really focused and dynamic without needing a new report each time.
You mentioned KPIs.
Yeah.
Key performance indicators. What are they exactly?
The source defines them as quantifiable metrics. They measure how well you're doing against a specific goal or activity.
So things like sales targets, customer satisfaction scores.
Precisely. They're crucial for tracking progress towards objectives. Are we hitting the targets? Where do we need to improve? KPIs give you the numbers to answer that.
Now, to actually get the data out, to query it, SQL is key.
Absolutely fundamental. The SQL, structured query language, is how you talk to the database.
Asking for specific info, filtering, joining tables.
Yep. It's essential for retrieving data efficiently, building those complex queries needed for BI reports and analyses.
And BI is moving beyond just reporting what happened into predictive analysis.
Big time. Using stats, algorithms on historical data to forecast what might happen next.
Which helps businesses be proactive,
Right.
not just reactive.
Exactly. Spot potential risks before they hit, identify likely opportunities, optimize inventory based on predicted demand, that kind of thing.
The source also mentioned different data types we deal with. Structured versus unstructured.
Right. Structured data is neat, organized, Fits nicely into database tables, rows and columns, easy to search.
And unstructured is everything
Wow.
else. Emails, documents, social media, video.
Pretty much. Lacks a predefined format, much harder to process, but full of potential insights.
Both are really important for modern BI, even if unstructured needs more advanced techniques.
Definitely. Things like text analysis, NLP.
And we keep mentioning the tools, Power BI, Tableau, ClickView, the platforms where all this happens.
For the workbenches, yeah.
Data mining came up earlier, discovering patterns in large data sets.
Using those advanced algorithms again. It's how you find non-obvious connections, improve predictive models, really understand customer behavior deeply.
Speed and flexibility seem like huge drivers now. Real-time analytics and ad hoc reporting.
Yeah, real-time is analyzing data the instant it's generated, getting insights right now.
Critical for things like monitoring live website traffic during a big sale.
Or tracking stock market shifts, detecting fraud attempts as they happen.
E-commerce dynamic pricing based on live demand. The timeliness is everything.
Absolutely. And ad hoc reporting is about flexibility, letting users create reports on the fly.
Answering specific, maybe one-off questions not covered by standard reports.
Exactly. The benefit is agility. Marketing can see how a specific post is doing right now and adjust without waiting for IT. Addresses immediate business questions.
Okay, organizing the data effectively is key for performance. Data schemas, dimensional modeling. Star schema comes up a lot.
It does. It's fairly simple. A central fact table with all the numbers linked directly to surrounding dimension tables with the descriptive info.
Like a star. And that simplicity makes queries faster.
Generally, yeah. Fewer connections, joins needed between tables. Easier to understand, easier for BI tools to work with, popular for dashboards.
And the snowflake schema.
It's a variation. It takes those dimension tables and breaks them down further, normalizes them into more related tables.
Reduces data redundancy, maybe saves storage.
Right, but queries often need more joins so they can be slower, it's more complex.
So the trade-off is star is simpler, faster queries usually. Snowflake is more normalized, less redundancy, maybe slower queries.
That's a good summary from the source, yeah. You choose star for speed and simplicity, maybe Snowflake for complex relationships or storage optimization.
And fact tables versus dimension tables.
Yeah,
They're the core of this, right?
absolutely. The backbone.
Yeah.
Fact tables hold the quantitative stuff, the numbers, the metrics, sales amounts, units sold.
Dimensions provide the context. The who, what, where, when. Product details, customer location, time periods.
And in dashboards, the facts feed your charts and KPIs. The dimensions provide the filters and the ability to drill down.
Which relates to dimensional modeling itself. The whole approach of organizing data this way for analysis.
Exactly. Key features are those fact and dimension tables and also hierarchies.
Hierarchies let you navigate data at different levels.
Yep. Enabling drill down and roll up. Drill down is going from summary to detail, like annual sales down to monthly, down to daily.
And roll up is the opposite, aggregating up. Individual stores roll up to regions, regions to national totals. Makes exploring the data dynamic.
Okay, zooming out again. How does all this BI stuff actually support decision-making?
By taking all that complex, messy data and turning it into insights people can trust and act on.
Identifying trends, measuring performance, giving you the solid data to improve efficiency, plan strategy, moving beyond just gut feeling.
But getting there isn't always easy. The source mentioned challenges.
Oh, yeah. Data quality is a big one. Integrating data from all those different, often incompatible systems.
Getting people to actually use the new system, overcoming resistance to change.
That's huge. And just handling the sheer scale and performance issues as data grows.
Which is why businesses often need a BI roadmap.
A strategic plan, basically. Laying out the goals, milestones, resources, timeline for BI initiatives, a structured approach.
Moving into some more advanced concepts. Data governance.
Crucial. Ensuring data integrity, security, usability, setting clear policies, standards.
It covers things like data quality management, who gets access to what data, making sure you comply with regulations like GDPR.
Yeah, bad governance can lead to big trouble, legal issues, loss of trust.
And BI is increasingly cloud-based. Advantages.
Scalability easily grow or shrink resources. Cost efficiency often pay as you go. Accessibility get insights from anywhere.
Data security and BI, obviously critical.
Non-negotiable. preventing unauthorized access,
Yeah.
using encryption, strong authentication, constantly monitoring and auditing who's accessing what.
And a really hot area,
Man,
integrating machine learning with BI.
yeah, ML can automate predictions, find patterns even complex queries might miss, deliver much more sophisticated insights.
The source had examples like using Power BI with Azure ML for advanced sales forecasting.
Or Tableau with ML for anomaly detection, spotting weird dips in revenue or spikes in complaints automatically.
Even automating sentiment analysis from customer feedback using Python or R scripts within Power BI, it brings that predictive power right into the BI workflow.
We should also touch on roles. The BI developer.
Right, the architects and builders. Designing, maintaining the systems, ensuring data accuracy, building dashboards, integrating sources.
Their responsibilities cover that whole pipeline, bridging raw data and business insight.
And how does BI improve CRM, customer relationship management?
By giving real insights into customer behavior, identifying patterns, predicting churn risk, enabling personalized interactions.
Helping keep customers happy and loyal.
Exactly. Providing metrics on behavior, helping segment customers, measuring campaign success.
Benchmarking in BI, comparing your performance to others.
Yeah, against industry standards or competitors. Helps identify where you're strong, where you're weak, sets realistic goals, drives improvement.
And the impact of big data on BI.
It's huge. BI now has to handle not just massive volume, but huge variety, including all that unstructured data.
Which allows for deeper insights, better predictions.
But requires more scalable infrastructure and advanced analytical techniques.
Performance optimization for reports is always important too. Slow reports are painful.
Totally. Techniques involve making queries run faster, reducing processing time.
Things like database indexing, like an index in a book.
Right. Simplifying complex queries, caching frequently used data so it's retrieved faster next time.
Let's revisit those OLAP types. MELAP, ROLAP, HOLAP. Different ways to build OLAP systems.
Yeah, different architectures balancing storage and query speed. MELAP uses pre-calculated multidimensional cubes, often very fast, for specific analyses.
ROLAP uses standard relational databases, querying the detail directly. More flexible for huge data sets, maybe slower queries.
And HLAP is a hybrid, trying to get the best of both speed from cubes, flexibility from relational data.
APIs, application programming interfaces, how do they fit in?
They're vital for integration. Letting BI tools talk to other systems, connect to more data sources, share insights automatically, enables automation and customization.
And advanced visualization techniques, beyond basic charts.
Yeah, things like heat maps to show intensity visually, like website click hotspots, or geospatial analysis putting data on maps, like sales by region, conveying complex info effectively.
Project management is relevant too. Version control in BI projects.
Super important, especially with teams. Tracking changes to reports, dashboards, data models, using tools like Git, keeping clear documentation to avoid confusion.
Real-time data streaming. Processing data continuously as it arrives.
Yep. Essential for monitoring live sensors, website clicks, getting truly up-to-the-minute insights for operations.
Data quality best practices, a constant theme.
Because it underpins everything. Ongoing data cleansing, strong data governance, vital for trust.
And natural language processing, NLP, in BI, making it more accessible.
Yeah, letting users ask questions in plain English, show me last quarter's sales, and also extracting insights from text feedback, social media, makes BI easier for non-tech users, unlocks text data.
Handling really large data sets needs specific strategies too.
Like data aggregation summarizing data to reduce volume, and data indexing speeding up queries on large tables.
Sentiment analysis, using BI to understand opinions.
Exactly. Analyzing the emotion in text data reviews, surveys, social media helps understand how customers feel about products or services.
Great for analyzing feedback, monitoring market trends.
Definitely.
Okay, finally, the article spent quite a bit of time on a specific tool, Power BI.
Makes sense. It's hugely popular. Microsoft platform for visualization, sharing insights, decision support.
Connects to tons of sources, transforms data, creates interactive reports and dashboards.
Understanding the architecture helps. There's Power BI Desktop, where you build reports.
Power BI serves the cloud platform for sharing and viewing.
Power BI Gateway for connecting securely to on-premise data. And Power BI mobile apps.
And different tools like Desktop, Service Mobile, and Report Server for on-premise.
Connecting to data sources, Power BI supports hundreds. Key methods are direct query,
which queries the source live. Good for huge data sets or real-time needs.
Right. Or import data loading data into Power BI's engine. Faster reports, good for smaller data sets, offline access.
And the Power Query Editor is key here.
Oh, yeah. That's where you connect, clean, shape, transform the data before it even gets into your model. Vital step.
So the process for creating a dashboard, according to the source, connect data.
Then clean and prepare it using Power Query.
Build your visualizations, add filters, make it look good.
Then publish to the service and share it.
And two core concepts within Power BI, DAX and Power Query.
DAX data analysis expressions. That's the formula language for creating custom calculations.
Calculated columns, measures like total sales YTD, adding business logic.
Exactly. While Power Query is all about the data prep before the modeling and DAX calculations happen.
Okay, and the article wrapped up with some specific tips for data mining interviews.
Applying all this BI knowledge, key tips. Really understand the fundamentals, not just names, but how techniques like clustering, classification work, when to use them, algorithms like k-means, decision trees.
Reviewing BI tools like Power BI is important too, since results are often shown there.
Showcase analytical thinking, practice problems, explain how you'd approach analyzing a data set or solving a business problem. Your thought process.
Be ready for technical questions. Data preprocessing, feature selection, model evaluation, and brush up on SQL, Python, R.
Demonstrate practical experience. Talk about projects, internships where you actually apply these techniques. Show, don't just tell.
And finally, understand business context. How does data mining actually help the business make better decisions? Connect the tech to the value.
Wow, okay. We really did cover a huge amount there straight from that source article.
Yeah, from the absolute basics, what BI is, why it matters, to the core components like warehouses, ETL.
OLAP versus OLTP, data accuracy, metadata, visualization, dashboards, KPIs, SQL.
Data types, tools, data mining, real-time analytics, ad hoc reports, schemas, dimensional modeling.
The bigger picture of decision support, challenges, roadmaps. Then advanced stuff. Governance, cloud, security, machine learning integration.
Specific roles like BI developer, impact on CRM, benchmarking, big data.
Optimization techniques, OLAP types, APIs, advanced visuals, version control, streaming, data quality, NLP.
And that deep dive into Power BI architecture, tools, DAX, Power Query.
Finishing with those practical data mining interview tips, it really covers the landscape.
Yeah, pulling those key insights directly from the article gives you, hopefully, a really solid foundation pretty quickly.
Exactly. The essential pieces you need to get informed.
So, thinking about how fast things are changing, AI, machine learning, real-time data becoming standard in BI, what new questions do you think BI professionals will need to answer in the next few years? And how might that really change how businesses make decisions day to day?
That is a really interesting question to ponder, isn't it? The landscape is definitely shifting fast.
Thanks for going on this deep dive with us.